You've probably used slicing in Python. It's one of the first ways you learn to work with sequences in the language. But do you know all the ways that you can slice a sequence in Python? Today we'll review the basics and move on to more advanced use cases. Let's begin. Let's start with the basics. In Python, a sequence can be any ordered collection of objects. It can be a list, a string, a tuple, a set, or you can make your own. When we slice a sequence, all we're doing is extracting some part of that sequence. Let's check out some examples. Here our sequence is a list, specifically a grocery list of eggs, milk, goldfish, apples, and ramen noodles. To slice this list, or to get one part of it, we first need to know where all the items are located. And in Python, we use something called zero-based indexing. That means that every item in our sequence, or in this case a list, is giving an integer value beginning with 0. The first item has a integer or index of 0, the second has an index of 1, so on and so forth. If then we wanted to get the first item, we could refer to our sequence of grocery list and pass something in between this bracket. If we wanted the first item, we could pass in the value of 0 and we would get back our first item of eggs. These double brackets are called the indexing operator, and what you pass in is used to figure out how to get the items from that list. If we wanted to get apples, we would pass in the value of 3 and we would get apples as a result. Now there are situations when you want to get more than one item, and that can be done by passing in two numbers separated by a colon. Let's just see what happens when we put in a couple of values. In this case, we'll put in 0 all the way to 4. And you'll see that we get, in this case, eggs, milk, goldfish, and apples. And that's because we have eggs starting in position 0, and if we look at 4, we go all the way to ramen noodles. If you look closely, you'll notice that we're not getting this last item of ramen noodles. Even though we put in 0 to 4, our output is stopping at apples, or something in the third index position. And that's by design. When you pass in two numbers separated by a colon, the last item is not included. If we did want to get the full list, we could pass in something like 5. And we would get everything from 0 to 5, but not including 5. In this case, everything from 0 all the way to 4. Let's start writing some of this down. If we wanted to slice our list, we could pass in just some number like we did before to get one item. And if we wanted to get a range of items, we would put in two numbers representing our start and stop indices with a colon in between them. But there's more ways of slicing here. Maybe you don't want to get all the items in a range, but every other item in a range. That can be done by passing in a third value separated by another colon. Let's do that. Here, after the 5, we'll put in another colon, and let's just put in 2. If we run both of these together, not 22, just 2. If we run both of these together, you can see that 0 to 5 gives us the full list back, eggs, milk, all the way to ramen noodles. But when we pass in a step value of 2, you'll notice we start with 0, or eggs, and then we step 2 values over until we get to goldfish, and 2 values over again until we get to ramen noodles. So this third value is telling you what stride or what step you want to take through your list. If, for instance, we put in 3 instead of 2, then we would start with eggs again, since we're starting with a position of 0, and we'll go 3 spaces, 1, 2, 3, to get to apples. And if we tried to go 3 more spaces or 3 more items, we'd run out of things to get, and apples would be the last item that we get. So the full notation for our indexing operator is you could pass in a single number, or you could pass in start, stop, and step. Now there is something that I forgot to tell you. When you're putting in those two numbers for the start and stop position, you can exclude them, and when you exclude them, Python will just assume that you want the very beginning or the very end of the list. For example, if we passed in grocery list and we passed in, let's say, 2, and nothing for the stop value, Python will start with a position of 2 and extend the list until the very end, until you get to ramen noodles. Or, for instance, you could have nothing for your start value and something for your stop value. Python will extend the list to the very beginning, giving you eggs, and go until the 4th item of apples. But wait, there's more. What if you wanted to get the last item in the list and you don't know what the index position is? That can be done by using something called negative indices. If we want the very last item, we could pass in a -1, and Python would return to us ramen noodles. Or suppose that we wanted to get the last two items, we could pass in -2 as our starting position and nothing for our ending position, and we would get apples and ramen noodles as the last two items. Here you can see in the comments that I've identified the positive indices as well as these new negative indices. When you use a negative index, the last item is given a index of -1, and it works backwards until you have -2, -3, -4, and -5 in this case. And you can mix and match the positive and negative indices. For example, if you wanted to get everything from milk to apples, you could, for instance, type in grocery list with a positive index to capture the milk and a negative index to capture everything to apples. In this case, I'll do -1, and we will get milk, goldfish, and apples. Or if you want to get the entire list in reverse order, we could pass in nothing for the start and stop, and pass in a -1 for the step value. And we would get the full list, but in backwards order, from ramen noodles, apples, all the way to eggs. Those are the basics of slicing. When you slice a sequence, you just need to know where in that sequence the item you want is located, and you can target that by using positive indices or negative indices. Likely, you've already learned this when you took your Intro to Python course. Let's now think about what's happening behind the scenes. What exactly goes on when you pass something between the square brackets? Well, in Python, two things happen, specifically when you pass something with a colon inside of it. Python will first take the input between the square brackets and turn that into a slice object. And then that slice object will be passed to the sequences __get item __ method, or _get item, or dunder get item method. And it's up to the logic within get item to do something with that slice object. We can verify that this is true by just testing it out. Here below, I've defined a custom class. It's called myCoolSequence, and it has one method defined, the dunder get item method. This is a very simple method. All it's doing, it's taking the positional argument that it receives, in this case called index, and passing it back so we can see what's going on. We'll define our class and initialize it as the letter S, or the variable S, and let's check out some examples of what happens when we pass something in between these brackets. Passing in S0 just returns the same integer of 0. Kind of boring. But if we move on to something with a colon between them, you'll notice that in this case, we don't get just 1:5 back. We get something called a slice object with values of 1, 5, and none. And that might sound a little bit familiar. These are the start, stop, and step parameters that we saw earlier. If we did pass in a step value, we can see that we get a slice object of 1, 5, and 2. And if we passed in nothing, then we get a slice object where none is the value of each of these parameters. Most interestingly, if we pass something with commas, that turns into a tuple that's passed to the dunder get item method. Here we have 4, 6, 1:5 passed in, and we get that tuple with each of those components, and the part that has a colon is converted into a slice object. Well, why does that even matter? Well, most of the time, it doesn't matter. In most cases, you're using sequences or classes that have been built by someone else, and you don't need to know about slice objects or the dunder get item method and how it works. But there are situations when you move on in your Python journey and you want to build things that are a bit more efficient by maybe making your own classes. And today we'll just look at a few examples of advanced use cases for slicing. The first one is from data engineering. Now, if you're blessed, you receive data that's clean, perfect, and requires little to no cleanup. If not, you're a data engineer, and you've likely had to receive a text file that looks like this. Here we have orders in a text file, and whoever created the file has decided to use fixed column widths for each field. We don't know why, but we have to deal with it. One way of processing this file is to read the text file in with Python and parse each line to identify where the columns are and do what we need to clean that up. Here's one way you could do that. In this case, we are somehow reading in our text file as a Python string, and later on we're going through each line to do something with that information. We could isolate the columns by reading each line and using indexing. 0 to 10 would give us the order number, like 1001, 1002, 1003. 10 to 35 could give us the item description. 35 to 43 could give us the unit price, and we'll do a little bit of cleanup there. 43 to the end would give us the quantity. But just look at all of these numbers, 10, 35, 43, you have to keep track of all of these. And suppose that you had a large file with hundreds of columns, and 6 months from now you have to go back and make changes to the logic. It can get a little complicated. What if instead of having to do this, where you have indices to identify each column, you had something like this? In this case, we've replaced our indices with variable names that make it easy to understand what we're doing. All we need to do is to define these variables. In this case, we're explicitly creating slice objects that still give us the same ranges of start and stop, but we're shoving that into variables that can later be used in our logic to process the file. In this case, for example, we're going from 0 to 10 for our order ID, 10 to 35 for our description. Later on, when we process each line, we refer to that variable or that manually created slice object. This makes readability tremendously easier, and in the future, if you need to debug or make changes, you can quickly figure out what's going on to make those changes. You can also slice your own class. When you create a custom class, you have the choice to handle slicing by defining your dunderGetItem method. Let's check out an example. Here we have a class called Spellbook, and this spellbook is going to store the spells from the Harry Potter universe and allow us to slice or search the spells that we've loaded into the spellbook. We'll go through the code later, but for right now, let's just examine what this class is doing and how we can slice it. I've initialized our spellbook as spell_book and loaded our few spells. Before we go through the logic, let's see how slicing works in this class. If we pass in the letter L with no colon, then we'll get back the spell beginning with that letter. If we pass 2 letters with a colon between them, the class is designed to return all the spells beginning with letters between that start and stop letter. How is this being done? Well, if we go back and look at our code, we'll step through the spellbook to see the magic. First, when we initialize the spellbook, we define one custom attribute called spells, and it's an empty list to begin with. This is where we'll store the spells that are loaded into the spellbook. We have a method called addSpell, which does the obvious. It receives an incantation and appends it to our spells list. Another method, getSpellByFirstLetter, performs our search and returns any matching spells. Specifically, we start by initializing an empty list of our search results, and then we go through all the spells that are in our spells attribute and just check to see if the spells begin with letters that are in the letters variable passed to it. If so, we append it and return those search results. And our dunderGetItem method is handling the slicing for us. Remember, when you use the indexing operator or those square brackets and you pass something into the square brackets, it's the dunderGetItem method that receives what you put in. In this case, we have logic to handle the different scenarios. If we just get a single string or no colon, then we'll pass that string to the getSpellByFirstLetter to perform our search of spells. But if we pass in something with a colon, we know that the dunderGetItem method will receive a slice object. And in that case, if what we receive, the search key we receive, is a slice object, we're doing a little bit of manipulation to perform the search appropriately. First, we'll take that slice object and rip off the start, stop, and step values, storing them into temporary variables. Later, we figure out all the letters between the start and stop letter that were passed in. That's done by using the variable ASCII uppercase from the string module. And if you haven't seen that, you can quickly check it out by importing string and executing string.ascii uppercase. It's just a list of the uppercase ASCII letters from A, B, C all the way to Z. In our class, we're using that variable to figure out where in this string of ABCs our start letter is, where our end letter is, and then we're figuring out all the letters in between them by performing a slice of that string. That is later passed to our getSpellByFirstLetter method again to search all of our spells for spells that begin with letters in that range. Now, this can be a little complicated, and I don't want to scare you with the details here. The main thing to pay attention to is this. When we define this class, we defined a custom dunderGetItem method. And within this method, we define what to do if we receive just a single value or something separated by colons. And in the situation where we received a slice, we captured that slice object and extracted its contents, bending it to what we wanted the slicing operation to do. This is an example of how, when you create your custom classes, you can define a custom dunderGetItem method to implement slicing. It can make the class more user-friendly for whoever is working with your code. Python is easy. It's a beginner-friendly language and you can start coding very quickly with little experience. But it's also easy to miss some of the advanced features that the language can offer. Today we saw, again, how we can slice sequences using the indexing operator, or those square brackets. But we also saw how we can create our own slice objects explicitly and use that to make our processing jobs easier. We can also make our custom classes sliceable by defining our dunderGetItem methods. I hope you learned something useful today and this helps you on your Python journey. If you have any questions, please leave a comment below. And if you like what you see, please like and subscribe. Until next time, happy coding.